So let's look at some example problems and see if we can solve them. And I'm just going to rewrite those two essentially algebraic definitions for even and odd symmetry. So for even, we know that when we plug in minus x into our function, we just get back the original function. Or essentially, when you put in the opposite x value, you still get the same y value. And then we also have the odd function symmetries, and that's when we plug in the opposite x value, we get the opposite y value. So essentially, in both of these cases, we're going to plug minus x into our function and see if we get either the function back or the opposite of our function back. So let's do that for this particular equation here. So we have f of minus x, and anywhere we see an x, we're going to replace it with minus x. So we have 4 times minus x plus 2, and this simplifies to minus 4x plus 2. But this is neither the function nor the opposite of the function. And to see if it's the opposite of the function, I'm going to factor out that negative. So we'd have minus 4x minus 2. So it's the opposite of 4x minus 2, but that was not our original function. And since we didn't get back either our function or the opposite of the function, we can conclude that for this particular one, there is no symmetry, or at least there is no even or odd symmetry. So in this one, we have to choose the option of neither. And moving on to the second example, we're going to do the exact same thing. We're going to plug in minus x anywhere we see an x in this function. So we have the cubed root of minus x, and then minus negative x. We're replacing negative x with this x here. And now we just want to simplify. And you can actually take a cubed root of a negative number. Now, if this was a square root of a negative number, that would be imaginary, and we wouldn't be able to graph that. But you can take a cubed root of a negative number. For instance, if you had the cubed root of minus 8, this is simply equal to minus 2. Or another way to look at that is that you can essentially separate this into a product of the cubed root of 8 times the cubed root of minus 1. And the cubed root of minus 1 is just negative 1. So this becomes, like I said, minus 2, or you could write it as minus the cubed root of 8. So in other words, we were able to essentially factor this negative out of the cubed root. So we can do that same thing here in just a more general sense. We don't have a number here, but the exact same principle applies. We'll be able to essentially factor this into the cubed root of x times the cubed root of negative 1. And then this simplifies to just plus x. And this cubed root of negative 1 is just negative 1. So we have minus the cubed root of x plus x. And to determine if this is either the original function or the opposite of the function, what we're going to do is factor out this negative. So we have minus the cubed root of x minus x. But notice this right here, this is our function. So when we put in the opposite of x, we ended up getting the opposite of our function. And when that happens, we know this is an odd function. So anytime you put in the opposite of x and you get back the opposite y value, you know you have an odd function. And if we got back the same function, we would have an even function. So let's look at a third example now. And we're again just going to apply the exact same process. So we're going to put in minus x anywhere we see an x in our function. So we have 1 over 4 minus x squared, but now we're replacing that with minus x. So we have minus x squared. And when you're squaring a negative, it always becomes positive because minus times minus equals positive. So this is just 1 over 4 minus x squared. But this right here, this is our function. So when we put in minus x into our function, we essentially just got back out our function. So when you put in the opposite x value, you got the exact same y value. And that is the key feature of an even function. So for this solution, this function has even symmetry. And we can talk about these symmetries in more general terms. And basically, you can always follow this idea of plugging in minus x and seeing if you either get back the function or you get back the opposite of the function. If you get back the function, we know it's even. And if you get back the opposite, we know it's odd. Now, a quick pattern we can learn is that, let's say we have the function x to the fourth minus 2x squared plus 1. So if your function only has terms in it that are even, when I put in the opposite of x, all of these end up becoming positive. So let me walk you through that just so you can see it. So we have f of minus x, so we'd have minus x to the fourth minus 2 times minus x squared plus 1. And when you raise a negative number to an even power, the negatives essentially cancel out, because you have 4 negatives multiplied together, and every pair of them is a positive number. So this ends up becoming just positive x to the fourth. This minus x squared, using a similar argument, would just become positive x. So we have minus 2x squared, and then plus 1. But notice this right here, this is the function we started with. This is just f of x. So when we put in the opposite of x, we got back the original function. So this right here has even symmetry. And we should expect that because it only has even terms. Now, if I added in an odd term like 1x, then this would no longer be even. And in fact, it would have neither symmetry. So when you're combining even and odd terms, you end up not having any symmetry at all. And just to further show this point, we can look at a function, let's say g of x is equal to 3x to the third minus 5x. And in this one, we only have odd terms. We have a cubic term and we have an x to the first power term. And so we're going to apply this idea. We're going to plug in minus x. And essentially, anytime you have an odd powered term, you're going to end up pulling a negative out of it. So let's plug this in. We have 3 times minus x cubed, then minus 5 times minus x. And when we simplify these, we have 3 negatives multiplied together. So when you pair 2 of them off, it becomes positive, and then you have a positive times a negative, which is a negative. So this becomes minus 3x cubed, and this becomes plus 5x. And to determine if it has odd symmetry, I'm going to factor out a negative. And when I do that, I get minus 3x cubed minus 5x. And this right here on the inside, this was our original function. So this is equal to f of x. And so when this is equal to g of x. And when we originally put in the opposite of x into our function g, we ended up getting back the opposite of g of x. So when we put in the opposite of x, we got minus g of x, and that is the key feature of odd functions.